so now that we got that all squared away, you have these notes page. This is our basics with complex and imaginary numbers. And we revolve around this whole idea that there's no way to take the square roots of a negative number. Even if you type it in your calculator, if I try to take the square root of any negative number, and I click enter on my calculator, it's going to tell me there are non-real answers. The real numbers are all the numbers we know and use every day. You can't find the square root of -1 with real numbers. Okay? It gives us an error in our calculator. Now, the square root of -1 can be solved. We just can't do it using the normal numbers we use every day, so we have what are called imaginary numbers. And whenever you take a square root of a negative number, your answer will be imaginary. You'll have this little I. Whenever you square an imaginary number or take an imaginary number to the second power, you will end up with a negative answer. Okay, that's the whole idea of imaginary numbers. Now, they act a lot like variables, so there's no better way to do this than to just start knocking out some problems. So if we look at number 1, just by looking at number 1, you see that we're taking the square root of a negative number. So you know our answer has got to be imaginary. So the first thing you're always going to do is when you see a negative underneath the square root, the only way to make this number underneath the square root positive is by writing an I in front and getting rid of the negative sign. So we're going to rewrite this as I square root of 121. We know that this is an imaginary number. Okay? By writing an I in front, I can make the number inside a positive number. Okay? We're going to have an imaginary answer. So now it's just exactly what you guys quizzed on. We can ignore the I for now, and we need to take the square root of 121. So hopefully you still have your perfect squares chart. You'll still be using that this topic. Is there a perfect square we can divide 121 by? 121 is a perfect square. It's on your sheet. Look at it. 121. What's the square root of it? 11. So our answer isn't just 11, but it's 11i. The square root of 121 is the real number 11, but because we were taking the square root of a negative number, we know our answer is imaginary. We get the imaginary number 11, 11i. It's an I. A lowercase I in math has a tail for whatever reason, but this is an I. Okay, let's take a look at number 2. Same thing. There is no two positive or two negative numbers that can be multiplied to get a negative number still. So we know because there is a negative under the square root, this is going to give us an imaginary answer. So put your I out front and make the inside positive. I square root is 63. From here, it's what we know and love, what we just spent a couple weeks learning, simplifying a radical. Square root of 63, sadly, is not a perfect square. So we need to break it up like we did. What perfect square can I divide 63 by? 9. So I can split this up into the square root of 9 times 7. Just like we did. Okay, and then I get I square root of 9, square root of 7, break the gang up. I know the square root of 9 is 3. In math, we don't like to write I3. It's weird that way. I is like a variable. So we write 3i square root of 7. that make sense? Just like we don't write x3, we always write 3x. So just make sure the I is attached and behind your number. Okay. 3I squared is 7. Okay. Pretty much the same as what we've done. The only thing is when you have a negative number on the inside, get rid of that negative at the beginning by putting I out front. Since we know the square root of -1 is I, that's why we're allowed to bring the I out. Okay, so those are simplifying radicals that are imaginary. Number 3. I might need to move these down a little bit so we have a little bit more room. The second thing we need to be able to do is we need to simplify imaginary numbers. Now we just simplified square roots that had imaginary answers. Now we need to simplify terms. This is a term, 2I squared is one term. We need to simplify this. And you might be like, well, how do I simplify this? We're going to simplify it using this simple, tiny, little definition. I squared is the same as -1. Wherever we see an I to the power of 2, I can change it into -1. So 2I squared is the same as 2 times -1. That's it. We can take I squared and just rewrite it as a -1. 2 times -1 is -2. Okay? This is going to show up a lot. A lot of times throughout this topic, you will have I to the power of something, and you'll need to simplify that. I squared is our definition. It's just -1. Which makes sense. These are really the same thing rewritten 2 ways. When you take the square root of a negative number, it's going to be imaginary, which means if I take an imaginary number and I take it to an exponent, it's going to go back to being real. Okay, number 4. I have a good trick for how to do this one. We know I to the power of 2 is -1, but we don't know what I to the power of 3 is. So we're going to rewrite number 4 a different way to help us out. Okay, so I'm going to rewrite my -5. That's not going anywhere. I to the power of 3 means I times I times I, right? It's to the power of 3, so it's the number to the power. A number to the power is a number times itself that many times. That was confusing. I to the power of 3 just means I times I times I, right? I times I times I is the same as I to the power of 3. The reason we're writing it this way is because we know every 2 i's is going to turn into -1. So if I kind of group these 2 i's will turn into -1. Does this I have a buddy to help turn it into a -1? No. So it's just going to be left there. So we're going to rewrite this as -5. I times I is I squared, so that's just going to be -1. And our last I at the end, our third I, it has no buddy. It has nothing to help turn it back into a real number, so it's just going to stick around. -5 times -1 is 5. I's got no friend. It's not going to turn back into a real number, so it just chills out. Does that make sense? This page isn't impacted either. I don't know. Alright, 2 more.
Is this the nicest that you did today?
Yep. Alright, number 5. 3 times the square root of -12. What should I do first? What do you notice? It's a lot like the ones we did on our quiz yesterday, except there's one difference. How do I get rid of that negative right off the rip? What do I just put out front? An I. I can just rewrite this as 3i square root of 12. That gets rid of my negative number and I don't have to worry about it. Because I have a negative number under the square root, I instantly know my answer is going to be imaginary. I can't multiply a number by itself to get a negative number unless I have an imaginary number to help us out. The square root of 12 can be simplified, can't it? Right? The square root of 12 breaks into what? Yeah, 3 and 4 or 4 and 3. 3i is still chilling out front. Keep on pulling them apart. 3i, square root of 4, square root of 3. Again, this is just like what we did. The only difference is there's an I hanging out now. I know the square root of 4 is 2. So I have 3i times 2 square root of 3. If I have 3 imaginary numbers and I multiply it by 2, now how many do I have? 6. It's just like 3x times 2 is 6x. 3i times 2 is 6i. The square root of 3 that was at the end, there's nothing I can do with that. It can't be simplified. I can't put it in my calculator because it's a gross decimal. I just bring it along. 6i square root of 3. Okay? Again, the only difference between this problem and what you've learned in the past is at the beginning, we took out the negative from the square root and made it an I. Alright, number 6. I to the power of 5. How many i's are there? An I to the power of 5. 5. I times I times I times I times I. 5 i's. I times I times I times I times I. Okay, and the reason we're writing it out this way is because every 2 i's are going to turn into a negative 1. So we're going to make some groups. I and I, they have a buddy. They're going to become real again. I and I, 2 i's. Those are going to become real again. Like Pinocchio wanting to be a real boy. And this I at the end, any buddies? I itself, his wish is not going to be coming true. He's going to stay imaginary. I times I is negative 1. I times I is I at the end, nobody to turn him real again. He's going to just hang out at the end. Negative 1 times negative 1 is 1. So we have 1i, which is a perfect answer, or you could just write I. I to the power of 5 is just I. That's so weird, isn't it?
Wait, is that an I or front?
Right here?
No, right below.
This one? Just an I. It's not a very well drawn I, but it is an I. Alright, we're going to quickly introduce what a complex number is. And then I believe you guys got some problems you're going to work on. We'll see. We'll see if we want to do the next section. Okay, a complex number. So imaginary number is just a number with an I attached to it. 2i, 3i, anything with just a little I attached. All the things we just did, those were all imaginary numbers. A complex number is a combination of real and imaginary numbers. Okay? So they are in the form a plus bi, which is this gross looking math thing that probably doesn't mean a lot to us. But if you have a real number plus an imaginary number, it creates a complex number, which I think that's a good word for it. Like a number that has a real part and an imaginary part, that sounds complex, doesn't it? Complex number. Real and an imaginary. Here are some examples. 4 minus 6i is a complex number. The 4 is our real part. The minus 6i, that's the imaginary part. When they're together, it creates a complex number. A real part, an imaginary part. 6i plus 4. Okay, this one's out of order. It's the same as 4 plus 8i if we just flip them around. 4 is the real part. 8i is our imaginary part. Together, it makes a complex number. 7 plus I, same thing. 7 is real, I is imaginary. Together, when they're being added together, it makes a complex number. 12i minus 6, we have our imaginary part, we have our real part. Together, it's complex. So imaginary numbers are the numbers with the I attached. When we introduce a real number with an imaginary number, we call them complex numbers. Okay, so with that said, at the end of your packets, there are all the practice problems that will be due when we quiz on this in a couple weeks. So far, we have covered, with those little baby notes we've just done, these first two boxes. So on the top, it says simplifying radicals with imaginary numbers. You now know how to do those 4 problems. Right below it are simplifying imaginary numbers. You know how to do 1, 2, 3, and 4. So there are 8 problems you know how to do. We will attack adding and subtracting tomorrow.